Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing an unassemblize tool. The GUI is what we want to complete. But there is still a lot of work to be done. Okay, so we said we want to submit the changes that we have done in the previous video. Okay, so okay, so we made these two functions and this and then we created the tip on hover tab. Then we did this thing. We added this to do. We added this implement. How about here? The implements. How about we add a imgui text unformatted, not implemented. Okay, let's see. Not implemented. Good. Good. Create string, blah blah. Simplify. 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 File tab. Title. Simplify file tab. Title code. Simplify code for file tab title. There we go. Okay, commit. Next. Well, let's stash. Verify that this compiles, but I think it does because we never make mistakes. It works. Stash pop. And now the next is we added the first, edit empty window. Erase. Remove this. We can What we could also do is, so basically what it does here, every frame it checks if one of these is set. Which, yeah. Yeah. I mean, the alternative would be to have to check here. I think this is fine. This is fine. No, even with 1,000 elements, it would still be fine, but I don't think someone opens 1,000 windows. Yeah. Okay. Maybe we should name this differently. Maybe we name it like this. Okay, how about we add a tooltip to this thing? Begin menu. We can probably also scoped menu bar, menu bar. Menu bar dot is open. Then we can remove this. Then here we do scoped. We can also do scoped window. This is const expr. Flags window background window. We do if window is content visible, scoped menu file menu. If menu dot is open, tools. If menu dot is open, there we go, and menu. Okay. We can. No, that's fine. Let's rename this to window flags. And window open. Okay. Okay, here we say open a new assembler comparison window. Opens in here. Opens the program file manager window. Opens files. Supported program files can be loaded here. Can be set up here. Okay. Let's see. So it's about this one here. Oh, well, that doesn't look right. Okay, so where we toggle, we cannot have a question mark. Okay, well then we remove it here. No big deal. Okay. Good. Then let's see. Okay, so this is fine. This is also fine. This is fine. Blah, blah, blah. Yeah, blah, blah. Okay. Then we name this add ASM comparison descriptor and Windows for it. Use imscoped for some windows and menu bars. Add some comparison descriptor and windows for it. Management and Windows. Yeah. Okay. Commits. Good. There's that. Next. Next, we want to remove all the indices here. So, size T index. Size T index. 0. Okay, so the idea is as we iterate this thing, Okay, so file manager body. So here we iterate this stuff. Okay, so I would say we do here descriptor index equals I. So we always update that thing, and we do the same on here. No. Here descriptor index I. So now the index is always in sync. Yeah. Okay, that's good. And then that means we can now remove all these indices here. Yeah. Okay, we can start here. So remove this index. And here. Okay, that already looks much better. Then here we do descriptor dot index, descriptor index. Another thing we could do is maybe we don't operate with indices, but with IDs, similar to how we do IDs with the command. Because then at least those IDs would be stable, which I think is desirable. Let me think. Let's see if this compiles first. Yeah. Okay, so let's see. It is used. So it's used for the browse buttons. And it's used for the title. And that's it. Okay. Okay, so what we can do is So in our work queue, we also have this ID concept here. Command ID. Okay, how about we start our IDs actually at 1. Then we go to command ID. Good. Oh, where is it? PDB, no, ImGUI app here. Let's do using program file ID uint 32t. Oh boy. And ASM comparison ID the same. Then we do index T, index Z, and program file ID is 0. Okay. I think what this also means is in our work queue, invalid work queue command ID, active command ID. How about we make our invalid command ID 0 instead now? Zero. Then we make this invalid +1. 1. Oh. What? How is this an overflow? It's 0 + 1. How is this an overflow? That makes no sense. Good. So it's ID index. Yeah. Then we do the same here. ID 0. right, ID, and we do invalid ID. Yeah, no, don't just put it 0. Okay, then let's put a static program file ID as ID. It should be private. Is it also private here in our work queue? It is not. Let's make it private. Okay, then let's move it down here. Private, and this can also be const. Then we create a constructor. That will be ID is sid plus plus. And we do the same for this one. And then put this down here. SID. Good. And then we go here. So that would be, oops. This is ID. This one. Okay. And I think that should be it. ID. Blah, blah. Yeah. Yeah, I think that's it. Yeah. Good. Then we say here file. We don't use index anymore, but we use ID. And the same here, ID. Okay. And then let's see. File. Okay, let's see where index is used. Here, I think here we can also use ID. All right, there we go. Good. Okay, great. Let's see if that works. So basically, we should now have stable file IDs. When we remove a file, it should no longer decrement. So we add a file here, and now we remove number 5, and number 6 remains number 6. Yeah. You can add new ones, 7, 8. Yeah. Okay. Good. Yeah. Oh, this one shows an empty hover tooltip. Oh. Okay, let's fix that. Hover. Here. City string exe name that const if not exe name empty. Maybe we make it shorter. Just tooltip. Let's keep it exe name. Okay, short tabs. Oops. Okay. Okay, good. It does show an empty lines. Begin tab. There is a mistake here. If show files and this. We should move this in here. No, we don't. This is correct. Okay. Good. Let's see. Good. So work queue. Wait, we also need to test if the work queue works. Okay. So now the ID should start at 1. And it does. 1, 2, 3, 4. Yeah. Okay. And then, well, that's it. End of test. End of test. Good. Then we can close that. Good. I mean, the index is not used now, but maybe we keep it for now. Maybe it's useful for something. I don't know. Otherwise, you can remove it at some point. Good. So we have a private SID. constructor sets it. Wait, there's a mistake here. This needs to be const. Maybe index shouldn't be here then. If it's not used, remove it. Active command ID. Okay, how about we move this guy here. Then we have this here. And this should be pretty compact. Yeah. Okay. Good, then we remove this and this. Yeah. IT. This we can also use ID here. Descriptor ID. Okay, so basically if we open this and then we close this and then we open another, then we open comparison 3. Good. And if we open another, we have another. Good. All right, good. Descriptor ID. All right. Good. So work queue, we changed that and that. And here we introduced ID, removed all the indices. Index, okay. And we've also fixed this bug here. Fix that bug. Simplify that. And that. Okay, replace program file indices with IDs. With unique IDs. Replace program file indices with unique IDs. And also fix showing empty tab bar and empty tab tooltips. Tab item tooltips. Fix empty tab bar and empty tab item tooltips. Good. Done. Okay. Okay. So next, there is already something we need to think about. The chaining of commands. I think the way it's implemented right now, or is meant to be used, is not so convenient, because what we do, let's go to loads async exe pdb here. So what it does is we provided a callback, the lambda function, and in the callback we then chain another async file call, function call. But this is a problem. Like if we like let's say we wanted to chain load pdb, load exe, and then a comparison of no, we want to chain load pdb1, load exe1, load pdb2, load exe2, and then a comparison of these things, right? So there will be 5 things chained, but we can't effectively write this with the way it's currently implemented here. Like we can't chain this properly. So we would need to have a facility to say, hey, I have this chain. And also it needs to be separate chains. So you can say, this is one chain, this is the other chain, and the chain maybe joins here, and both chains are required to keep on the next chain, right? So let's get here professional paint. Yeah, super professional. We take a big fat brush here. So we have PDB, yeah, and then after this we load exe, yeah, and then we have a second file which is just exe, so like the game does, right? So we load this, and then once these things are loaded, then we can do comparison comp. And it could also be multiple comps. So it could be maybe comp 1 of one subchunk, and then comp 2, right? So right now we don't have an effective way to chain these things together. we have a very simple chain where we say, okay, after PDB is done, we immediately chain exe in the callback, right? So we can build a chain, but it's not great because we need to hard code in the callback what it needs to do. This is not good. Okay, so how can we implement this? So also here we have two chains, right? So 1, 2. They don't need to be on one line, these things. They can be on two separate chains. But then they meet here. And here both chains need to be done when this starts. Oof. Okay. Okay, so currently our work queue, the command, it accepts just the work function, the callback function. Fair enough. Okay. Okay, I think we need another structure to define the chain of commands. Chain of commands. That sounds funny. So so okay. So how would it work? Let's say we have a struct where you can just push multiple commands that are meant to be executed in succession. Yeah. And then we pass this to the work queue. What does the work queue do with it then? It would have to push this thing, this queue command, work queue chain commands. It would have to push that into a queue. And then what? It sits in there. Well, okay, this is maybe a little bit more complicated. The work queue needs to work one. So right now it works on one item after another, which makes the work queue simple, right? So, but it needs to. So we give it a chain of commands. Well, needs to work. We can only add we need to pass a result from the previous. Okay, the reason why we use it in the callback right now is because we want to use a result of the previous work in the callback. So now the question is, do we just want to use the previous work or all the previous work? Right? Like we could receive a vector of results. But then first vector. Vector commands Q. Okay. There. It will. Okay, we need to first think like high level approach. High level. So currently we push always to a command queue here. Everything goes in there. Everything goes in there. Well, if we it is in the callback that we make the decision whether or not we want to chain. This in the condition. In the callback. Oh boy. Oh boy. Okay, so shit. Okay, let me look at the problem once more here. So the problem is, if we now wanted to run a comparison, then we would first need to load the PDB, then use its result to load the exe, and then afterwards use these things to do the comparison. So it's a chain of events, and one depends on the other. That's a problem. There must be a solution. I'm not seeing it right now. I'm not seeing it. We want it to be elegant. Right now, the way we use it is not elegant. Because we have this nested chain of callbacks. Callback. PGP reader. Descriptor. Wow, this stuff. I still don't have a good idea. Chain. Can we... Come on, callback. Chain. Maybe the chain needs to be instigated somehow differently. That we don't do it in the callback, but there is like an extra function for chaining. Would that work? So we have callback, and then we have chain. Chain. So you do something in the callback. Let me think. So let's say we do the PDB, we get the callback called, and there we update the PDB reader pointer and the time point and blah blah. And then that is done. Validate command ID. So our callback, let's say we keep our callback always clean. We just use it to use a result and set something. And then we have a chain function, and the chain function but I don't understand. If we Okay, the main goal is we want it to be flexible. We want to chain in different orders, so to say. Chain this and that. It's not easy. Maybe it is easy, but I just don't see it right now. Can we chain it? Okay, and even now, it's even easier because our queue is on one thread, so we don't even have to worry about parallel queues. Just one queue. But we want to chain. That's the important thing. Just chaining. Don't care about parallel queues, okay? For starters. We just want to chain correctly, which we currently do by adding stuff in the callback and then going deeper, basically issuing another command in the callback once we have the data from the previous callback. Yeah, which is fair. Like if we have a chain of commands, we can always use a lambda to build the chained information. Like let's say we load the PDB, which we already do. We load the PDB, we save the result in the descriptor. We load the exe, we save the result of the exe in the descriptor. If we now do a comparison, we have the stuff in the descriptor. It's there, right? So this is fine. This is perfectly fine. Okay, so what we can do, load. Yeah. Callback. I have the impression there is some easy answer to this, but I'm not seeing it right now. Well, it looks like we just spent this video just thinking. Well, but thinking is part of the. Okay, how about we ask our friend ChatGPT for some ideas? So let's give him. Let's go to our work queue. So Okay, let's just copy this. This should be enough to work with. Here. Let's open your chat. I have a C++ work queue. Have a C++ work queue with a work function and a callback function. The work function is called on a I have a work queue class that takes commands. That takes a work queue that takes a work queue command that has a work function and a callback function. The work function is called on the work queue threads. The work function is invoked on the work queue threads, which is different from the thread that pushes the command to the work queue. With inside the callback, we can use the result of the current finished inside the callback function. We can use the result of the finished command to chain a new command. This works all right, but has disadvantages when setting up more complex code to chain a series of commands. How can we, what strategy can we use to facilitate command chaining on our work queue? Here is the command structure, command structs. Something is wrong here with the input field. Yeah. Okay, let's see what ChatGPT says. Command chaining. Make it more intuitive for more complex sequences. You can adopt a feature-like API or a chaining API. Use a mechanism that allows commands to describe dependencies and chain execution naturally without requiring manual setup inside the callback. Chaining mechanism. Introduce a method like then in the work queue command to define the next command to execute. Should know its dependent commands. Chaining support. Modify to support chaining through a then method that creates dependent commands. Let's see what. Chain another command to be executed after this one. Work. Chain commands. Would this work for us? So we set the first. Yeah, I think it could work because we say first we have like load PDB if it doesn't exist, if it's not already loaded. Then load exe, then do the comparison. Yeah, then first command, chain command. Yeah, it kind of makes sense. Then, okay, I see. Yeah, I see where this is going. Next commands. Work, callback. Next commands. Yeah, maybe this will work. Yeah, I have to say, ChatGPT, he knows his work queues. Yeah, he knows his work queues. What is this mutable here? I don't even know what that means. Ah. Give it. I like that ChatGPT also puts like this stuff here. Okay, chain another command. Okay, I think this is a worthwhile direction. Introduce a method like then to define the next command to execute when the current one completes. Yeah. Each command should know its dependent commands. Each command should know its dependent commands. Yeah. And the work queue should automatically enqueue them when the current command completes. How do we do that though? Chain another command. Chain another command to be executed after this one. Okay. Next commands. Use the result from the current command. Use the result from the current command. Get chain commands. What is this function? Well, it's not here. Chain command. Store the result. Chains. Okay, so after the callback, we could get the chains. Chains. Okay, let's try to draft this implementation. I'm still not 100% sure. Okay. Command ID. Okay, so chain another command. Let's see. So this is our function. Next work. Next work. This result. What is this result? Probably means this here. Callback results. Yeah, I think it's going into the right direction. But this is weird because then um chain. Okay, so his idea is to store the result. Store the result in the chain command. Yeah. Okay, what do we currently do with the result? So I think this is weird though that we would give it a functor here, because callback. Next. First command, then work. It's weird. It's weird because it passes here another like callback thingy. So this is already, no, this is work. But then where? Okay, he didn't put a callback to this guy. Okay, and then he passes this. So this would be the work, but it's weird because then here you do next command. This result. I'm a bit confused by this. How about we store the next command in the command? So here we would have a work queue command. Work queue command ptr next command. And this next command so we pass here ptr next command next, or just command next command. Let's call this new command. Next command std move new command. Return next command get. How about that? So we just chain. So we call it, so we create a command and we call then another command, and then we can call again then on the next command. And so this command now owns the next command. Okay, update callbacks. Moves the callback to decommit. Try DQ. Now the question is it legal to enqueue in here? Probably. Yeah. I think it will be legal. What's the correct? Let's call back. Results. Command callback, result. Results. And then, all right. callbacks. So update callbacks. Okay, so we have a polling queue and a callback queue. How would we be able to chain on both these? Polling queue. Well, the command is in the results, and the command contains the next command. So it would have to be done manually. Update callbacks. Okay, I don't think we can do anything here. And then let's do it here. Move the callback to decouple from the result. Move the callback. Okay. Callback results. Okay, and then if results hold on. Callback. This one can modify it, can reset it. Okay, maybe it shouldn't be allowed to reset it then. Very sure. We say if results gets what? If result gets, it's not null pointer, and results commands next commands dot get, what is it? It's not null pointer. Then command queue dot enqueue enqueue next commands. Enqueue. Oh, let's just call enqueue std move. nqs nqs. My gosh, I can't write. nqs next command if it exists, if present. nqs next command if present. Okay. Okay, so basically, when our callback is done and we haven't stolen the results, which we currently do, I think, but we can remove that. Let's go to MGUI app. So we call this result reset. Let's remove all that. No longer resets. Okay. So if we don't steal the results, then there is a next command. Then we enqueue the next command. And the next command contains a new work and a new callback. Yeah. And since we have this result here and we pass it as reference, the callback has the power to drop the whole result, or even like reset the next command. That would also work, right? You can break the chain if you like to, right? Yeah. So the callback has the power to like still control the next command. And he can also go into the next command and change it. Like, so the command, like here, when we go to our PDB, no, runner, where's it? Runner async here. Like these options, for example, right? So if he knows what kind of type the next command is, then he can edit it. So he has full authority, basically. Okay, it gives flexibility, but is it easy to use? That's a big question. Is it easy to use? Work here. Chain another command to be executed after this one. Yeah. So basically, yeah, this one is just a, like, it's not that this function is not strictly necessary. It just allows to chain this as a function chain. But essentially, the important thing is that we have next commands. Okay, then we probably also want a helper function to create this thing for us. Let me see. How do we currently create it? Let me see. Runner MGUI app. Okay, so currently we created with make unique, and then we edit it afterwards. Okay. Make unique. Yeah. Okay, let's compile what we currently have, just to see if it compiles. And it does, okay. We didn't change much, but it's good. Keeping things simple is much appreciated. Okay, so I think, let's try to write this right now to facilitate what we do. So we don't chain in the callback, but we chain already in advance. So we have, let's do it. Let's rename this to pdb commands. Loads pdb commands. And there we set the callback. The command is already in here, which is pretty straightforward. It just sets what does it do? It sets a work, what it should work on, yeah. Okay, so we just set the callback. And then we have an auto loads. I see. We ideally want to reuse this thing here, right? This stuff. We probably need a function that says make create load exe command that just gives us a command, right? Just but hold on. We still need to set all these things here. Well, this can be part of the create command. Yeah. All this is part. Maybe even the assert. All this is part of create load exe command. And then it enqueues it here at the bottom. And here we chain it. Yeah, okay, I think this will work. Okay. Yeah, I think so. Okay, so we need async load exe command. Async load exe command. Yeah. So but hold on. can load. Yeah. Okay, let's create a. Let's see. But this is a problem. No, this callback. I don't. Okay. I think this doesn't work because when we call this function to this logic to assemble the chained command, the next command, then all the stuff here is evaluated with the descriptor as it is known at that moment before we have loaded the PDB, which is wrong. So this is correct because here it issues a load command after all this has been updated here, the stuff. So we need to preserve this kind of thing. So there needs to be a delayed call to this. We cannot do it before. And I think this is what ChatGPT tried to use here, to do here with this next work thing. That it says you give it a functor as next work. Okay, how? Yeah, how about we just give it a next work functor? Next functor, next. Would that work? So instead of a next command, we give it a next functor. Which essentially is the same as a callback. Yeah. I think the key here is to separate this logic from this NQ, so that we decouple this creation from this NQ. I think that's a key. Oh boy. And we have a functor. 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 So we don't give it the next command straight away. We give it a next functor. And the functor determines what we do, which is similar to our callback. Okay, so if there was a next functor, let's say here, so we have callback and we have next. Next. And what do we pass in next? This is weird. Like, this is weird because I think this is wrong. Like, because if we create a unique pointer here, what is it doing then? Here it returns next command, which is created here. I have no idea what's going on here. Well, it looks weird because the chain command is now here. It's a unique pointer and it will go out of scope here at the end of it. So it is destroyed. I don't understand. Like, I think that something is not right here. But I think the direction is okay, but I think the implementation is bonkers. But I'm not 100%. Okay, but so the way I see it right now, we need some kind of next function. So we don't chain in the callback, but we chain in the next function. Now the question is, what should this function, what should it take as arguments? Should also take the result. Maybe. But I'm so confused. Work Q, then next work. So next work he wants to pass. He passes it here. Next command. Work. Callback. Yeah, this is also weird that it modifies the callback here. Yeah, that's not nice. We don't want this. Boy. Callback next. Yeah, I think ChatGPT is missing a lot of context about the actual implementation of the work queue. That's why he can't come up. Okay, let's. So chaining. The problem is we cannot save a next command in here because we don't know the state of this next command at this point. So we need a pointer. We need a function to call on next, but then we cannot chain it like that. Chain another command. Next command. Cannot chain it like that. Okay. Next. The problem is maybe we need to chain a different kind of structure, like a delayed command. The delayed command has a lambda function. So delayed command, work queue delayed command, and the delayed command. I don't know. Can we do this? So struct work queue delayed command, and here we have a delayed command, delayed command, delayed command, delayed command. Oof. And in here, we have a function creates commands. Create command, and the create command returns a command pointer. And the delayed commands delayed commands, and this one returns let's go delayed commands, next commands. Or let's call it delayed commands. Let's call this delayed. Delayed delayed function, or delayed commands. Well, let's say delayed work. Delayed work. Then we create a delayed command std make unique make it a pointer, then delayed commands, delayed work, assign that delayed work, and then delayed work. So we have delayed command, delayed work. And then what? How can we pipe this through? So work commands. Yeah, maybe maybe we need the same thing here, and here we return delayed work. Delayed work. So basically, we only want to create the command pointer later, right? We want to delay the creation. So it's delayed work. And here, how about we create then a next delayed commands, and here. So work queue commands. So delayed commands, next delayed command, then. Delayed command. So we can make a public work queue delayed command. And then we remove this here. And we move this here. So there is now, so we give it the delayed work, which is a lambda. And the lambda is saved here. Hold on. Well, we need to write it. So delayed work, this delayed work equals delayed work. Maybe we just make it this std move. I hope that is legal. Let's pass it like this. Okay. Next delayed command. Delayed command. Okay, so now there's a question like, well, we need to allocate here next command, but then there's one wasted of this. That's weird. So if this is part of that, next. Delayed work. Yeah, it's a bit weird. So basically here, if we do this, and then we return this. So this way we could chain this delayed work now, but it means that the last pointer has an empty delayed work. So it's allocating in advance, but the last one may not be used at all. That's a bit weird. Can we do it better? It looks weird which makes me believe that there's something wrong, you know. But it looks to me like it would work in principle, but it's weird that now. So this delayed work is part of the root work queue command, and it at the same time it's also a delayed command. Maybe. Maybe we should say that here next delayed command, next delayed work is delayed work. And so okay, this would mean that now the next delayed command is not useless, but the delayed work within the first instance here is useless. Because it doesn't have delayed work. It is. So what we could do is we could make this a composition, move it here as a member, but then is there any drawback? No, maybe not. Then okay, what we can do is we make this a member. But then we cannot call this function because it's no longer part. Well, we would have to make a copy. Yeah, we would basically then have to create here a copy like this, delayed work. And then we would have to delayed command, make unique, delayed work, delayed command, next delayed command. And then, yeah. Okay, so now we wouldn't have a wasted delayed work thingy here. Is it worth it? Maybe it's better to make this part of work queue command, but then it has this delayed work thingy, which is useless. Maybe we make it private. I don't know. Well, what we can do is we have delayed command and make another struct work queue delayed is. Delayed commands. This is delayed work. Command. Yeah, I think it should not be here. I think it should be a public this. So it's always this one element here. Okay. But it does mean we made a mistake somewhere. Ah, here. So it does mean we have one useless delayed work function here in the root command. But maybe that's fine. It just sits there, does nothing. Yeah. It just sits there. Yeah, I think it's fine. Should be fine. Good. I think this approach could work. So we have delayed work. We give it a result. Okay, how do we implement this then? Let's see. In the work queue here. Next command if present. So if command next delayed command. Next delayed command. Then we do std move command next delayed command. Oh boy. Delayed work, and we give it results like that, right? Yeah. Delayed work and queue. Delayed work. Well, the question is, do we really need to enqueue? Hold on. Do we need to enqueue actually? Delayed work. Probably. So we only enqueue the root. But if we do delayed work, if we do delayed work, yeah, it kind of makes sense that it enqueues it here. Next command. Okay, let's add some delayed command point. Next delayed command. Okay. Delayed work function to create a new command. To chain a new command after the previous command has returned its results. Delayed work function to chain a new command. The new command is created. No, yeah, I mean, that's implicit with the message. Delayed work function to create and chain a new command after the previous command has returned its results. Has completed its work and has returned its results. Oof. Okay. Let's remove this stuff here. Okay, will this work? This looks promising, this approach. So basically, we all kick off with a work command, yeah. And the work command also has concept of a delayed command, and the delayed command is simply a callback which hands over the result and expects that the delayed work creates a new command pointer, a new command. And if we get this command, how about we say here, hold on, delayed work. Let's do the following here. Result, delayed work, results. Let's do here commands equals that. And then we do, assert. We expect that we are given a command, right? Assert commands is not null pointer. And then move commands. Yeah, if the delayed work doesn't give us a command, then there's no point in the delayed work. If someone wants to cancel delayed work, then he should do it in the callback by removing next delayed commands. Right? Makes sense? That's right now we expect that the delayed command is valid. Yeah, I think this is going into the right direction, but it's possible that I missed something and then maybe I'm on the wrong track, but it looks like this can work to chain commands freely. That we have control over the order, and basically we just need to provide just a callback that describes, okay, what command will be created at this time. And then it can call like a function that does a work, and then it just creates this new command at this time, and then it enqueues it and it's done. And aha, hold on. There's one more consideration here. Command, delayed work, hold on, delayed work. So right now, this thing owns this, the next one. So we need to hand over, hold on, command. So we need to also hand over command dot, no, command, next delayed command equals Jesus. Delay, next delayed command. Yeah, so next delayed command is this, and then this next delayed command, which may be null, right? Std move. Oh boy, deleted something. Results. Right? So if our current command has a delayed command, and the result is also still there, next command if present. Let's say evaluates and enqueues. Evaluates and enqueues, next command if present. Yeah, so here we get the command, and in the command the user just creates work and callback and context. He doesn't necessarily change the next command, but he could. So we can say he could. So he could create a new chain in there. What happens then? Oof. So let's say we have a chain in our root command, but then the user here with a delayed work creates a new chain in there. What happens then? I don't know. What happens if the user creates a new chain in a chained command? Because essentially we then have two chains. Like let's say we have, so we start off with one command, two commands, three commands, and they all chain together, right? And then here, this is a delayed command which is created, but then let's say this also chains to a command. What happens then? Because then we have two. Well, how about we chain? Oof. It doesn't seem right to change the head of chain. Like if we are here and we get our command, then the next chain commands should be stable. It shouldn't like insert this one here and then move it one back, because then the result that the result that this expects, or both expect, is then maybe different. So that doesn't seem to work. So there's different options. Either we replace a chain completely, so we drop this one and we accept the new one. That would be a possibility. Or or we say it's not allowed. That's also a possibility. Unexpected. Did you create a new chain? Yeah, either we replace a chain or we don't allow it. So right now we don't allow it because we just override it here, right? So if a delayed command was set, it would be overwritten here. The alternative would be we check if this is null and then only set it. This would mean that the chain can be changed with a new command, with a delayed command. Right? Oh boy. I don't know. Come on. Expects valid commands. So we could create an assert here and say that this is expected to be null pointer. Expects no new delayed command chain. Here. Expects no new delayed command chain. But what if the user really wants to create a new chain? With user, I mean us. Right now, I don't see a use for this. Like we just chain a bunch of commands and then we let it run. Or do we ever do we expect to change the chain for expects no new command chain? Well, the user could Maybe there's a valid reason the user could say, hey, I want a new chain, right? Yeah. Okay, let's say if command delete chain is null pointer, then we set it. Otherwise, we lose the original chain. Let's say else, and we add a comment, loses original chain. Loses original command chain here. Well, I'm pretty sure that this doesn't compile. Loses original command chain if next delayed command is set. Command chain. If a new next delayed command is set. Lose original command chain if next delayed command is set. Yeah, so the user really needs to know what he's doing if he wants to do that. He can do it, has the power. But maybe, yeah. I mean, what's the alternative? If we are presented with a new chain, what can we do? We can't just create a command result. Well, yeah, maybe the user wants to reassemble his command chain in some way. So he has a result, which means he has access to the command chain. So the user could like reorganize the chain of commands for some reason. Like he could do it. It's essentially, this is a linked list, this thing, right? So he could relink this. Yeah. And then we say, if the relink has already happened, then we don't link ourselves. Yeah. Okay, let's add a note here. Note the next delayed command. Hold on. Next delayed verb next. So the result. Command. Note the next delayed command is this. The next, the delayed command at the time of callback is this. The delayed command at the time of callback is result command next delayed command. Yeah. Oh boy. Okay, but I think it's this could work. Yeah. Okay, I need a break now. Has been 3 hours. Oof. Whoa. Time has been passing. We didn't get much done. It was mostly thinking. But I think there is an idea now. There is an idea which is very different from what ChatGPT has proposed. But ChatGPT, at least it gave us the initiative to think about this. Right? So, yeah. ChatGPT does not always give us a right answer, but it helps us figuring things out. Yeah. So that was good. Okay, but I think this might be working for what we want. Yeah. Okay, we need to see in the actual user codes how we interact with the queue, but I think this might be good. Okay, I will take a break. I wish you a great day or night. Until next time, goodbye.